You're hanging with Hussick. This one's about solving algebraic equations. So we're going to go through some single-step, some one-step and two-step processes in solving simple algebraic equations. All right, so an equation and an example of an equation is shown right here, okay? So x plus 3 equals 5 would be an example of an equation. It's a lot like an expression, but it has an equal sign, as you can see here. And it can be simplified or expanded, similar to how an expression can have that done. In this case, x plus 3 equals 5 is quite a simplified version of this equation. But unlike expressions, the variable, in this case x being the variable right here, has a defined value. That means as soon as you put the equal sign in and you set the whole thing equal to something else, it means instead of x representing any possible number, like we saw with expressions, x represents a defined number. So what this means is that an equation always has a solution, or it can always be evaluated or solved. And the way you do this evaluation or solving is by isolating the variable, which means you get the variable by itself on one side of the equal sign. So let's practice doing that, because ultimately that's what you have to be able to do. You have to be able to solve equations. All right, so let's solve this bad boy. So that would be the prompt would be, solve or evaluate this. Okay, so how do we solve this? Well, you look at what is being done to the variable. So find the variable, there it is. Okay, you look at what's being done to it. And it's having 3 added to it. So what you do is you do the opposite to that. You do the opposite to that in order to isolate the variable. So we're going to subtract 3 from that side, and we're going to subtract 3 from that side. So whatever you do to one side, you also do the same operation to the other side. So do the same operation to both sides, okay? So we're going to go ahead and subtract 3 from each side. If you subtract 3 from this side, now x is left by itself, because 3 minus 3 is 0, so it's like x plus 0 or x minus 0, which is just x. And then on the other side over here, you have 5 minus 3, so we can go ahead and write that out. X equals 5 minus 3, or x equals 2, okay? And now when you're learning this for the first time, what I would encourage you to do is you may orate it to yourself. You may say it to yourself, well, something plus 3 equals 5. I know that something must be 2. And of course, you could even check your answer. You could plug it in and check, okay, does 2 plus 3 equal 5? Yes, of course it does, right? Left side equals right side. But what I would encourage you to do is follow the process of trying to do the opposite operation as the opposite of what is imposed on the variable, so that you can isolate the variable. I'll give you some more examples of this. More examples, more examples. Okay, these would be just solve these equations. All right, so if you look at the first one here, we want to isolate x. What is x having done to it? It is having 6 subtracted, so we're going to do the opposite. We're going to add 6 to each side. Okay, the opposite of subtracting is adding. The opposite of adding is subtracting. So over here, it's going to cancel out to 0. So we're just going to be left with x. We have successfully isolated that variable, and x is going to be equal to 14 plus 6, which is 20. So here, x is equal to 20. You could sub that in. 20 minus 6 is 14, and you could check your work as well. Over here, let's do it again. So here we see that in example 2, x is being divided by 3. So what's the opposite of dividing? Well, it's actually multiplying. So we're going to multiply that by 3, and we're going to multiply this side by 3. Remember, whatever you do to the left side, you have to do to the right side. That's the rules. So if you take 3 divided by 3, it becomes 1, and it drops out. In other words, you could look at it over here. It'd be like having 3x over 3, which we saw before will cancel out to 1. Or it'd be like, ultimately having 1x, which is the same as just x. Okay, so if we multiply by the same thing we divide by, we are going to eliminate that, and we're going to isolate the variable, which is our goal. So we have x equals 4 times 3, which is 12 in this case. And again, you could sub that in. 12 divided by 3 is 4, and it works. And then here we see that we have 6y equals 30. So 6 is being multiplied by y. To eliminate that, we're going to divide by 6. We're going to divide both sides by 6. It's going to cancel out the 6 and leave us with y equals 30 over 6, which is equal to 5. Okay? More, solve, solve, solve. Okay, if you look at the first one, oh, by the way, I advise you pause the video, try it yourself first. If you look at the first one here, example 4, we see that x is having 13 subtracted to it, so we're going to add 13 to each side, and we're going to find out that x is equal to 6 plus 13, which is 19. Over here, example 5, we have y being multiplied by 3, so we're going to divide each side by 3. So we're doing the opposite of what's being imposed on that variable. And that way we're going to be left with y equals 39 over 3. 39 divided by 3 is 13. Okay, so y equals 13. And then same here, we have 8 being multiplied by z. We're going to divide by 8. Okay, to isolate the z, isolate the z. And 24 divided by 8 is 3. So we have z equals 3 there. These are all examples of what we would refer to as one-step type problems, one step, because in each one of these we really only had one operation that we had to do. So if it gets a little bit more complicated, you may have to solve two-step equations, and so we'll have a look at those next. All right, if there are some equations you have to solve using two steps, you may recall that if you want to, solve questions using the order of operations, you have to implement BEDMAS. Well, we're going to kind of unravel it the other way when we're solving two-step equations. We're going to use BEDMAS backwards, basically. Okay, we're going to use, what is it? SAMDEB. Okay, SAMDEB. That's what we're going to do. We're going to first get rid of subtractions and additions in order to isolate the variable. And next, we're going to do multiplications and divisions in order to isolate the variable. Okay, so let's take a look at a two-step one, something like 2x plus 5 equals 11. So this would require two steps to solve. First, we're going to do what we see here, the addition part. Okay, so we have 5 being added. We're going to, let me switch up my color here. We're going to subtract 5 from each side. So it's going to leave us with 2x equals 11 minus 5. All right. And then the next thing we're going to do is we're going to do the whole multiplication division part. Because x is being multiplied by 2, we're going to do the opposite. We're going to divide it by 2 to isolate that x. Then we have to divide everything over here by 2 as well. So x is ultimately going to be equal to 11 minus 5 over 2. 11 minus 5 is 6, so it's 6 over 2, which is equal to 3. So x is equal to 3. Again, with these, you have a great opportunity to check your work. You can check it by subbing that answer into the original equation here and seeing if it works out. So you can do 2 times 3 plus 5 and see if that equals 11. 6 plus 5 equals 11. 11, 11. So we're good. It all works out. Ta-da! And let's look at a whole slew more of practice here. So these are all two-step equations that we're going to solve. And remember, we're going to solve them using reverse BEDMAS. So we are going to eliminate the additions and subtractions first in isolating each variable. So we're going to isolate x. We got to get rid of that 7 as being added. We're going to subtract it from both sides. So we're going to have 3x equals, that's gone, equals 13 minus 7. So that's 3x equals 6, and then divided by 3 to get rid of that 3 because it was multiplied by x. And then divide both sides by 3, so x equals 2. Again, you could, I haven't really left myself space for this, but you could go sub it back in and see 3 times 2 is 6 plus 7 is 13. Okay, you can check your work. And then B, we have x is having 6 subtracted from it. So let's add 6 to both sides to fix that. Okay, so we're gonna add 6 here. We're gonna add 6 there. So you get x over 4 equals -1 plus 6. -1 plus 6 is 5. So you're going to x over 4 equals 5. You're dividing x by 4. So to get rid of it, you're going to multiply the x by 4. And you're going to have to multiply the other side by 4 to be fair. Those are the rules of the game. 4s are going to cancel. 4 divided by 4 is 1. So you're left with x equals 5 times 4, which is 20. X equals 20. This one, you're going to subtract 7 to get rid of that. So you have 5x equals 32 minus 7, which is 25. So you're going to have 5x equals 25. X is being multiplied by 5, so we're going to divide by 5 to liberate that x and isolate that x. And you get x is equal to 25 over 5, so x is equal to 5. So many 5s. This one here, D, you see the x term is having 28 subtracted from it, so let's add 28 to both sides. 8 plus 28, so 36 equals 6x. So I like where this is going. The x is being multiplied by 6, so we're going to divide by 6. Do it to both sides, and you're going to end up with x equals 6. It's okay to have it front ways, back ways, like this, totally fine. Again, you could sub each of these respectively back into the equation and check your work, and you'd see that you've done just a fabulous job. So I hope this helps you solve 1-step and 2-step equations.